Hopefully I have that one up. And let's see. Here we go. Now this is in my own handwriting, so if you can't read something, just give me a holler. I'll help you out with it. So when we're factoring, here are our factoring examples. So the first one is greatest common factor. So we have a 7x to the third minus 14x squared plus 28. Now, first thing to note is all three terms do not have an x in, so x cannot be part of the common factor. They do, though, have a factor of 7 in each. This is 7 times 1, this is 2 times 7, and this is 4 times 7. So we factor out the 7. We factor it out, think about it as putting it out front, and then we're going to have three terms inside the parentheses, kind of the reverse of distributive property. And so then what do you have to multiply 7x squared by, or I'm sorry, x squared by to get 7x squared? 7. So we just put an x squared here. We need a minus 14x squared here. So we put a minus 2x, and there should be a square there. Sorry about that. And what do we need to get 28? 7 times 4. So we put a 4 there. Now we're going to do pretty much the same thing here. Now, when we have variables, we'll always factor out for the greatest common factor the lowest degree, the one with the smallest exponent. Okay, so we have a 49m b squared, a minus 35m squared b to the third a, and a 77m a squared b to the fifth. So the first thing I note is a is not in all three terms, so I cannot factor an a out. I have an m here, an m squared here, and an m here. My lowest power for m is 1, so I factor the m out. I have a b squared, a b to the third, and a b to the fifth. My lowest power for b is b squared, so I factor the b squared out. And then for 49, 49 is 7 times 7, 35 is 5 times 7, and 77 is 7 times 11. So that means 7mb squared is our greatest common factor. I'd have to multiply that by 7 to get 49mb squared. The 7 would have to be multiplied by minus 5 to get minus 35. M matches, to match up with m squared here, I have to multiply by m. B squared, I have to multiply with a b. And a, I just need to tack on here because I don't have an a in the greatest common factor. And then for 77, 7 times 11, the m comes out. The a squared I need to tack on, and I need a b to the fifth. So to get b squared times what gives me b to the fifth? It's b to the third. Okay. Factoring by grouping. Factoring by grouping basically uses four terms rather. We group the first two terms together and the last two terms together, just like we have here. And then we see what we can factor out. So in this first two terms, we can factor a 2y to the third out. That gives us a 3y minus 1. In this next two terms, we can factor at least a y out. So we factor that out, and that gives us 3y minus 1. Okay? So now, what we can do is now, since the 3y minus 1 is here, and the 3 minus 1 is here, it's a greatest common factor for this. So we factor that greatest common factor out, and that gives us a 2y to the third minus a y left over. Now, if I look carefully, this doesn't always happen, but if I look carefully, the 2y to the third and the minus y have a common factor of y. So I'm going to factor that y out of this set of terms as well. So we factor the y out, put it in front. That gives us 3y minus 1. That was our first greatest common factor here. And then the 2y minus 1 comes from factoring the y out of here and here. What happens when the leading term is not 1? Or I'm sorry, when it is 1? This is the best of all scenarios when we have a trinomial. We have an x squared plus a 7x plus 12. So this is the reverse of what we did up above when we multiplied two binomials together. So the first thing we do is we split the x squared up into x in one binomial and x in the other binomial. We need two numbers that add up to be 7 and multiply to be 12. Those two numbers would be 4 times 3. Now you might not find those right away. That might take a while, as you know, because you've done this before. 4 times 3 is 12, and 4 plus 3 is 7. There should be a 7 here. I don't know what I was doing there. And so we put a 4 and a 3 here. Okay, the next one, the next example we have on the sheet is x squared minus 5x plus 6. Okay, again, we split the x up here and here. We need two numbers that multiply to be 6 and add up to minus 5. Minus 2 times minus 3 is 6, and minus 2 plus minus 3 is minus 5. And so get this written out as x minus 2 and x minus 3. If we test this out, we can always multiply it out to see if it works. In this case, x times x is x squared. X times minus 3 is minus 3x. Minus 2 times x is minus 2x. So that's going to add up to be minus 5. And minus 2 times minus 3 is 6. Another example, x squared minus 3x minus 18. Same idea. We need multiply to be minus 18, so one of them is going to have to be negative. Add up to be minus 3. And in this case, that would be minus 6 times 3, would be minus 18. And minus 6 plus 3 would be minus 3. So we write x minus 6 and x plus 3. Somebody always asks, well, what if I put the plus 3 here and the minus 6 here? Doesn't matter. Okay? Doesn't matter. What if we have an xy and a y squared, or an extra variable here, where the variable on the end is squared and it's first powered with the other variable here? Well, we do pretty much the same thing. So the first thing we do is we look for two numbers that multiply to be minus 12 and add up to minus 1. Okay? So those two numbers in this case would be minus 4 and 3, because minus 4 times 3 multiplies to be minus 12, and minus 4 plus 3 adds up to be minus 1. Now the difference here is that in the second term, inside each set of parentheses, we put a y here. Why? Because we need a y squared and a y when we multiply out. And so instead of just putting a minus 4 and a 3 here, we put a minus 4y and a plus 3y. What happens when the leading term is not 1? I put some examples on here. We're going to do what's called the AC method, factor by grouping. Okay? Most of you have probably seen this before. You can do the trial and error if you want. That's fine too. You can do these any method you want. Okay? The point is, though, we have to be able to factor them. And so we have something like 6x squared minus 5x minus 4. The first thing we note is the leading term is always a, the last term is always c, and the middle term is always b. So we take a times c, the first and last term, get 6 times minus 4, which is minus 24. We need two numbers then that multiply to be minus 24 and add up to this b term of 5. So 8 times minus 3 multiplies to be minus 24. 8 plus minus 3 add up to be 5. So this 5x gets rewritten as 8x minus 3x using this 8 and minus 3. Now we do factoring by grouping because we have these four terms. Group the first two together. We can factor out a 2x. That leaves us with 3x plus 4. Now here's a rule of thumb to remember. When you're factoring by grouping, if this third number is negative, always factor the negative out and whatever else can be factored out. So when I factor the negative out, it changes the sign of everything inside the set of parentheses to 3x plus 4. That means the 3x plus 4 and the 3x plus 4 match up. So it's a greatest common factor, so we factor it out, 3x plus 4. That leaves behind 2x minus 1. So now it's factored. Let's suppose we have 2p squared minus 5p minus 7. So again, we're going to do the same idea. A is the leading term, c is the last term, the constant term. The middle term, b, is minus 5. So that means we need two numbers that multiply to be a times c, which is minus 14, and add up to be b, which is minus 5. So as it turns out, 2 times minus 7 does multiply out to be minus 14, and 2 plus minus 7 add up to be 5, negative 5, I should say. This is not always as straightforward as it appears. Okay, this step could take some time. So be patient with yourself. Okay? In any event, we rewrite this minus 5p as minus 7p and plus 2p. Since this third term is positive, I don't have to worry about factoring out a negative. Okay? However, this first set of terms, the first two set of terms here that we group together, I can factor p out. This next set, I really can't factor anything out other than a 1, so I'll factor the 1 out. Now we get 2p minus 7 and 2p minus 7, so we'll factor that out, leaving us with the p plus 1. Difference of squares, I'm sure you've seen it before. Difference of squares, I have a 9x squared minus 25. The 9x squared is 3 quantity squared. The 25 is 5 squared, and they're subtracted, so it's called the difference of squares. So the difference of squares is strictly a formula, and it's a squared or something squared minus something else squared factors into what we had to square here plus what we had to square here. That's one quantity. The other binomial is what we had to square first minus what we had to square second. And so since we had to square 3x first, we put 3x in both slots. Then plus and minus. You could have this as minus and plus too, it doesn't matter. And then what do we square second? The 5. So we put the 5 in both those slots. So for this one, 11x squared, y squared minus 225z squared. 11x squared, y squared is 11xy quantity squared. 225z squared is 15 quantity squared. And so we get 11xy and 11xy, then plus and minus, and then 15z and 15z. This last one, 50x squared minus 200, not the difference of squares, at least not yet. Now, I always look when I'm factoring to see if I can factor out a greatest common factor. In this case, I can factor out 50 because 50 is here, and this is 4 times 50. So let's factor out the 50. That gives us x squared minus 4. Now, x squared minus 4, what's left here is the difference of squares. I squared x here, and I squared 2 here. So that means I have an x and a plus 2, and an x and a minus 2 when I factor this part. Hopefully this helped. We'll have more of these videos in the future. So have a good day.